Hey everyone, today we are going to be talking about absolute value and distance. So we've already talked a little bit about absolute value and how absolute value is a distance from 0 on a number line. And we talked about how distance cannot be negative. So when we're finding distance on a coordinate plane, the rules are the same. So even though there are negative coordinates and positive coordinates, when we calculate that distance, it's going to be positive. So example 1 says horizontal distance between 2 points, and the y values are going to be the same. So you'll see that these points are directly across from each other, and the y coordinates are the same. So it says write the ordered pair for each given point. So -5, -4, and then -1, -4. So I can see that these y coordinates are the same. And I want to know the distance between these 2 points. Well, when I'm given a coordinate plane, I can just count the distance between the 2 points. So 1, 2, 3, 4 units. And when these two things are on the same side of the y-axis, I can take these two things that are different, these x coordinates that are different. Remember, distance cannot be negative, so I'm going to take the absolute value of these two things, and I'm going to do 5 minus 1 is 4. So that's where the 4 units comes from. So I can do it with the graph or without the graph. For number 2, very similar. So I can count the spaces. So 1, 2, 3 units is going to be the distance. And now I'm going to show where those 3 units can come from without the graph. So P is -5, -2. And Q is -2, -2. The y coordinates are the same, so I'm going to use the x's, and they are on the same side, so they're both negative, so I'm going to subtract them. 5 minus 2 is 3. So that's where the 3 units comes from. So number 3 and number 4, very similar. The points are still horizontally across from each other, but now they're on opposite sides of the x-axis, or the y-axis, I'm sorry. So if I count 1, 2, 3, 4, 5, my distance is going to be 5 units. So if I have the graph, I'm going to use it. But if I've just got my ordered pairs, -4, 2, and 1, 2, I'm going to identify the ones that are the same, and then I'm going to use the other ones. So -4 and 1, they are on opposite sides of the the y-axis. I keep saying the x-axis. The y-axis. So I'm going to add these 2 points together. 4 plus 1 is 5 units. So here I've got 1, 2, 3 units, so I know it's going to be 3 units. K is -2, 1, and L is 1, 1. Those y coordinates are again the same. So I'm going to do 2 plus 1 is 3 units. So it says, look at the 4 problems above and write a rule for finding horizontal distance between any 2 points in the coordinate plane. So for horizontal distance, if the points are on the same side of the y-axis, subtract. If they are on opposite sides, add. Because that's what I did. If they were on the same side of the y-axis, I subtracted those 2 x coordinates. If they were on opposite sides of the y-axis, I added the x coordinates. So now it says find the horizontal distance between -3, 4 and 7, 4. So my y coordinates are the same. I have 1 positive and 1 negative, so I'm going to add. 7 plus 3 is 10 units. Find the horizontal distance between -3.25, 6, or -6, and -7.75, -6. Those y coordinates are the same. My x coordinates are also the same sign, so I'm going to subtract, and it's always big minus small. So 7.75 minus 3.25 is going to be 4.5 units. In example 2, we're going to be finding vertical distance. This is going to look more similar to something that we did earlier this chapter with the bird and the person swimming underwater. But now again, we're going to look at same side of the axis, opposite sides of the axis. So this one, I can count the boxes again. So 1, 2, 3, 4. So we know it's going to be 4 units. My first point is 3, -1. My second point is 3, -5. This time my x's are the same, and my y coordinates have the same sign, so I'm going to subtract. 5 minus 1 is 4. Over here, I've got 1, 2, 3, 4, 5 units. I've got 2, 1 and 2, 4. Again, my x coordinates are the same, and my y coordinates have the same sign, so I'm going to do 4 minus, or sorry, this is 2, -4. Just kidding. So this is going to be 4 plus 1 is 5 units. So now I'm going to use the same rules that I used up above for horizontal axis, or for horizontal distance, and I'm going to apply that to vertical. So if my two signs are the same, I'm going to subtract. If my two signs are different, I'm going to add. So here, my x coordinates are going to be the same, and then the signs on my y coordinates are also the same. So I'm going to do 2 minus 1/2. What is going on with my pen? 2 minus 1/2 is going to be 1.5, or 1.5 units. For number 8, my 1s are going to be the same, and my signs are opposite. So I'm going to do 0.5 plus 0.5, and I get 1 whole unit. Then it says, find the distance between the points. Is it a horizontal or a vertical line? So first I'm going to look at which coordinates are the same. So these two coordinates are the same. This is going to be a vertical line. And then my signs are also the same, so I'm going to subtract. So 1 1/3. What in the world? So 1 1/3 minus 2/3. 1 times 3 plus 1 is 4/3 minus 2/3. So my distance is 2/3. For number 10, my y coordinates are going to be the same. That means I'm looking at horizontal distance. And my signs are opposite, so I'm going to do 3.5 plus 0.5, and I get 4 units. I'm going to add units to this. Okay, so a lot of it is understanding which side of the axis you're on. And which coordinates are the same. So we're going to be using our highlighters again, identifying coordinates that are the same. When I find the ones that are the same, I'm going to use the other coordinates. And then it's all about, are those signs the same or are they different? Because if they are the same sign, you're going to subtract. If they are opposite signs, you are going to add.